So in part A, we're given a right angle triangle with sides that are 6 centimeters and 8 centimeters in length, and we are required to find the hypotenuse of the right angle triangle that's represented by C. So by the Pythagorean theorem, we know that C squared has to equal 6 squared plus 8 squared. Now if I evaluate 6 squared and 8 squared, we get nice numbers, 36 plus 64. Adding up 36 and 64 together yields 100. And C will simply be the square root of 100. And we all know that the square root of 100 is equal to 10. In other words, if we were to square 10, okay, then we end up getting 100 or C squared. In part B, in a similar way, okay, we have to find the length of the hypotenuse represented by C. So C squared will be equal to 12 squared plus 5 meters squared. I'm going to evaluate the squares. 12 squared is equal to 144, and 5 squared is equal to 25. Now adding 144 and 25 together, we're going to get 169. And if we take the square root of 169, lo and behold, we're going to get a very nice round number. Okay? And in fact, it's equal to 13. Now, given that the length of the sides of this right angle triangle were expressed in meters, the hypotenuse also has to be expressed in meters. And going back to part A, the hypotenuse of this triangle has to be in centimeters as such.